Hi, and welcome to our discussion on precipitation rates. We're looking at point measurements, point rainfall measurements, and we are working our way through accumulation gauges. We went through the theory of accumulation gauges, and now we're going to look at specific types of accumulation gauges for rainfall. So, first types. The first type is the ordinary, and then we'll also look at high resolution rain gauges, accumulation rain gauges. And the ordinary rain gauge is one that has a constant area from the top all the way down to the bottom. In other words, the opening's the same. There's no funnel or anything like that. So typically, these are very often made of plastic, and they'll have a scale right on their display that you can read right off, and that might be in inches or in millimeters. The problem with ordinary rain gauges is that the resolution is not very good. In other words, it's really hard to measure down to 1/100th of an inch of precipitation. Probably the best you can do is maybe 1/10 of an inch or even sometimes 1/2 an inch. And the way you record this is you look at it and then you estimate the amount of precipitation and then you write it down. Typically, we empty these once a day. I have a rain gauge at my home, and I belong to the CocoRa's rain gauge network, which I report every morning at either 6 or 7, depending upon if we're in Central Daylight Time or Central Standard Time. And as I said, doesn't make a very good or very accurate measurement. I don't have an ordinary at my home. I have actually a high resolution. So we're going to talk about the high resolution right now. The high resolution has a variable area. Variable area means that a funnel is usually employed. The bigger part of the funnel is called the catch area. That's the larger area. And the smaller part of the funnel is the measurement area. So what it does is it takes precipitation over a larger area and then funnels it down, which in effect what it does is amplifies the amount of or the depth of precipitation. So it's easier to read smaller amounts. So if you get just a couple hundredths of an inch of precipitation, when you funnel it down into a smaller area, then you get a greater depth and you can estimate it a little bit easier. This is what the National Weather Service has used for a long time. They use the 8-inch, that's feet, it says 8 feet. That's supposed to be 8-inch non-recording standard rain gauge. And then there's another one also we're going to look at a little bit later in another video, and that'll be the Wedge rain gauge. So there is your 8-inch non-recording standard rain gauge, or SRG, standard recording rain gauge. As I said, it was a national weather standard for years and years, and actually they still use the 8-inch standard rain gauge at most locations. They make that measurement and then also use the ASOS measurement. So the high resolution rain gauge, the 8-inch non-recording standard rain gauge, is made of 4 parts. It has 4 parts. There's the measuring stick, which has more or less the display or the scale. The overflow can, which is the bigger can. The collector funnel, which is the actual funnel. And then finally, the measuring tube, which is the smaller area tube. Here are the components broken down a little bit. And you can see the funnel sits at the top, the very top of the collector can, the overflow can. The measuring tube goes inside the overflow can and sits underneath the funnel. And then we use the measuring stick when we want to make a measurement. The 8-inch standard rain gauge has a capacity of 20 inches of rainfall. So typical rainfalls, unless you're in a hurricane, you're not going to see 20 inches. Even large thunderstorms sometimes can produce close to 20 inches, but I haven't seen anything, at least in North Dakota. I think the record in North Dakota is close to about 15 inches of precipitation in a 24-hour period. And that is a lot of rainfall. The collector tube has a 2-inch capacity, which means that it can measure the up to 2 inches. And then once the rainfall is above 2 inches, it'll start spilling out into the overflow can, and then you have to use the overflow can to measure the amount of precipitation. With the collector tube, it has a 100th of an inch of precipitation resolution. So you can measure to the closest 100th of an inch. And we're going to go through a little bit of math here. I'm showing you the big can. This is the big can, what we call the catch area. This is the width of the funnel, the top of the funnel. We're going to say it has a diameter of D, and we know that for the standard rain gauge, that diameter is 8 inches. And as precipitation falls, it falls into the can, and you have a certain amount of water, volume of water, which you can figure out the volume by multiplying the area of the catch area. In other words, the width of the can, how wide the opening of the can is in its area, times the depth or the height of the water in the can. That'll give you the total volume of precipitation that fell into this standard gauge. Now, on the other hand, we have to put this amount of water. The amount of water in the catch area will be, if you used a ruler, it would tell you how much precipitation fell. But we said that the resolution is not very good. It's really hard to measure to the nearest 100th of an inch. So we amplify that with a funnel, and as a result, that water, that same volume of water in a smaller container, smaller diameter container, will actually rise higher. And because it rises higher, we can use a measuring stick that is graduated to the nearest 100th of an inch of precipitation. The volumes are the same, the heights are different. So the same volume of water, but the heights are different. And because the height is higher in that smaller area, that smaller measuring can, we can measure more precisely. So we're going to come up with a relationship that this volume will equal that volume, but then it'll bring into play the difference between the two diameters or two areas of precipitation of the can. So this is where we realize the volume of one is equal to the volume of the other, but the heights are different. So we come up with an equation. We saw on the previous slide that volume is equal to the height times the area. The area is, of course, the diameter divided by 2. That'll give you the radius squared. Pi r squared is the area of a circle. And then times h gives you the height. H is the height, and that'll give you the entire volume. So we have different diameters and different heights, but the volumes are the same. And as you can see in this equation already, the pi's will cancel out. Also, the 2's in the bottom there, dividing by 2's, those will also cancel out. If we do the math there, and you can see that we're left with the diameter of the catch area raised to the second power squared times the height is equal to the diameter in the measuring tube squared times the height in the depth of water in the measuring tube. So the volumes are the same. And this relates the depth in one tube compared to the depth in the other. Now the depth in the catch area, the bigger one, that's the actual amount of precipitation that fell. Let's say that is perhaps maybe 1 inch of precipitation that fell. You can see that when you funnel that into the catch tube, the measuring tube, it'll be much higher. So this 1 inch here is really 1 inch, but it's more than 1 inch in the measuring tube. And we do that because it gives us better resolution. It gives us greater sensitivity. Remember sensitivity? We talked about that once upon a time. So here's the math. You can solve for how high the depth of water will be in the measuring tube. Let's say that, like I said, in the catch tube, in the big catch area, the big can, we have 1 inch of water. If we take the ratios of the diameters of the tubes, we said for the catch area, that was 8 inches. The diameter of the measuring tube, we're not sure. But if we knew it, we can come up with the height for 1 inch of water, believe it or not. So that's the math behind the high-resolution standard rain gauge. If you don't like diameters, you can also do areas. Areas are a little bit harder to calculate, of course. We usually just go ahead and measure the diameter, and from that we can come up with a correlation between the catch area and the catch can and the measuring can. For our 8-inch non-recording standard rain gauge, we already said that this ratio is 10-1, meaning that if there is 1 inch of precipitation in the big catch can, in the big overflow can, then that would equal 10 inches in our measuring can. And you can see that it amplifies the depth of the precipitation. So what we really would record is 1, but what we have to do is come up with a measuring stick that is 10-1. In other words, 1 or 10 inches on a measuring stick would actually be 1 inch of water, the depth of water. And you can see that on the measuring stick, and I'll try and take a picture and include that in our presentations in the future. But we have one of these at UND, and also they are at most National Weather Services. You can see these. So that's a little bit about the high-resolution rain gauge, and specifically we're talking about the National Weather Service standard rain gauge. We talked about the standard 8-inch non-recording rain gauge. That's a standard of the National Weather Service for a number of years. Now we're going to talk about backyard measurements, and specifically the Wedge rain gauge. The Wedge rain gauge, also known as a fence post rain gauge, is a gauge that is tapered, where it has a larger opening at the top and a much smaller area. Actually, it's infinitesimal at the bottom. It comes down to a point. So the name wedge implies that it looks like a wedge. What this means is that since the area is much smaller at the bottom of the gauge, that means the sensitivity is much higher. And then as you get higher, as you have higher and higher amounts of accumulation in the gauge, the sensitivity decreases because the area increases. Here's the equation for the Wedge rain gauge. Of course, this is a high-resolution rain gauge because it gives you much more sensitive measurements at the bottom than it does at the top. So it has a better resolution at the bottom. It can measure down to about maybe 1/100th of an inch. But the equation shows the difference between the actual height of precipitation and then the measured height, similar to what we discussed in the standard 8-inch rain gauge, where it funnels down and you have a difference between the actual height of precipitation and the measured height of precipitation. There's some pictures, what they look like, and you can actually get these online. Go out to Amazon, you can get one for about $14 for a really nice one, or you can go down to Menards and get one for about $5. So we looked at accumulation gauges. We've gone through the National Weather Service standard 8-inch rain gauge and also the Wedge gauge, and specifically these are high-resolution gauges. In our next videos, we're going to be looking at recording rain gauges. I hope you enjoy it.